And we're going to continue our topic of piecewise defined functions. And here's an example of how to write a piecewise defined function. It says a museum charges $5 per person for a guided tour with a group of 1 to 9 people for a fixed $50 fee for a group of 10 or more people. Write a function relating the number of people N to the cost C. So first of all, I want to point out that they gave us our independent variable. This is our number of people. That's our input. Input or X value. And C of that depends on N, the number of people, is cost. And this is our output value or Y value. Output. Okay. So we need to find a relationship between the cost, C, and N, the number of people. And the way you can tell that this function is going to be a piecewise is because there is two patterns, two basically schemes go on. So, or two different rules apply. So if we have a small group up to 9 people, there is one rule. Museum charges only $5 per person for that many people. So this is so C of N will be equal to $5 per person would be 5 times N, and that's for small groups between 1 and 9. But then after we reach 10 people, then our function, we're going to be charged $50 flat fee. So the rule changes to rule 2. So this is our rule 1. Rule 2 is just 50. No matter what N is, as long as it's 10 or greater. So this is how we write our piecewise defined function. So two different rules for different N values. If you have more than two rules, 3 or 4, you will just continue to list those rules and list the values of N that those rules apply to. Here's a different example. Here we already have a piecewise defined function, but we want to find values for different different output values for different input values. Okay, so here's the problem. A cell phone company uses the function below to determine the cost C in dollars for gigabytes, denoted as G, of data transfer. So again, we see two different rules. If we transfer 0 to 2 gigabytes, then it's we're charged a flat fee of $25. But if it's greater than 2 gigabytes, greater or equal to, then the company applies this rule for calculating your costs. So the formula for calculating your cost will depend on the number of gigabytes that you're transferring. All right, so we're asked to find the cost of using two different values for gigabytes, 1.5 or and 4. Okay, so we're gonna find the cost for transferring 1.5 gigabytes. So first, before you figure out what the cost is, first you have to figure out which rule applies to this specific value. So you're looking at the description of G. So our G is 1.5, which falls here. It's between 0 and 2. So that means that we're going to apply this rule. C of G equals 25. And that's it. Now for the next question, G equals 4. So where does it fall? Right here. Which formula describes, or which domain rather, describes our G value? Well, it's greater than 2. So therefore, we're going to use this formula for calculating the cost. So we're going to grab this rule right here, and it's 25 plus 10 times G minus 2. So our G is 4. So we're going to go ahead and substitute 4 in for G. And calculate the cost. 25 plus 10 times 2, which will give me 45 bucks. So for the cost for transferring 1.5 gigabytes will be $25, and the cost for transferring 4 gigabytes will be $45. So again, to recap how to figure out these function values for a piecewise defined function, you have to look at your input and determine which rule will apply to this specific input. Where does it fit? Does it fit into description 1 or description 2 for the input value? And then apply the corresponding rule to figure out the output value. And the last type of problem that I want to discuss in this topic in this video is how to graph a piecewise function. So right here we have 3 different rules for calculating my function. So it says when x is greater or equal to 1, I have this rule. For x's between 1 and 2, we have this rule. And for x is greater than 2, we have that rule. So what I want to do first is to divide our x-axis according to these regions, but mentally. Okay, I'm gonna actually draw the lines here, but actually when you see those graphs into publications, you won't see those dividing lines there. It's just for us to help us draw the real function. So what are the sections here on x? So one section is x is less or equal to 1. So right here, x equals 1. I'm gonna draw this line again. It's for my own, this is my reference line. And then the next section is x is between 1 and 2. So 1 is here, 2 is here. So that's your second piece is going to be between these two values. And the third piece is for x greater than 2. So it's beyond 2. So again, I have 3 pieces. X is less or equal to 1 up to here. And then x is between 1 and 2. And x is more than 2. Greater than 2. Okay, so now we can start drawing these lines. So the first one is actually x squared. So x squared is a parabola. I know what it looks like, so I'm gonna draw some points for me to help me draw a parabola. Okay, so this is my parabola, and I'm gonna start drawing. Okay, so, and I'm gonna stop right here because my parabola stops when x equals 1. So it only goes up to this point right here, up to this vertical line. Um, Again, do we include the end point? Because there is an equal sign here. Yes, we will include that end point. Now, the next is, so basically what this is saying is f of x equals x squared for x is less or equal to 1. And then next, f of x equals 3 for x between 1 and 2. So let's go to this one. So f of x equals 3 is our constant function, basically our horizontal line. And do we include endpoints or not? We do not include 1, but we include x equals 2. So above x equals 1, we have an open circle. Above x equals 2, we have a closed circle. Okay, so, and this is our piece of the function right there. Now, beyond x equals 2, we have f of x equals x. And that's our identity function. That's when the output is the same as input. So if the input is 2, then the output is also 2. When input is 3, output is 3. Input is 4, output is 4. So that's a straight line right here. Again, this line only exists where x is greater than 2. So beyond this point, beyond this line on the right-hand side. Do we include this point or not? Well, since it's x is greater than 2, that means the point above x equals 2 is not included. So it's going to be an open circle. So this is what our piecewise defined function looks like. And now we can actually draw it in. So it's this piece for x less or equal to 1, and then this piece for the x between 1 and 2, and then this piece for x greater than 2. So this is what the graph of this function looks like.